The best of Money Matters. The Big Story.
Welcome to The Big Story. I'm Hongbin Jeong. Dallas-based biotech company Colossal Biosciences has created 3 genetically engineered wolf pups, dubbed dire wolves, through a process of genetic modification and cloning. The pups, which exhibit traits from the long-extinct dire wolf, were made by editing the genes of gray wolves and using surrogate domesticated dogs to carry the embryos to term. Now, these pups are part of a larger ambition by Colossal to resurrect extinct species, with the company already working on projects like the woolly mammoth and the dodo. But how close are we to bringing back extinct species for real? And what ethical considerations come with resurrecting ancient animals? Well, to explore more about this, joining us today is Dr. Michael Knapp, who is the Associate Professor in Biological Anthropology at the University of Otago. Hi, Doctor. Thank you so much for joining me today.
Hi.
All right, Dr. Knapp, Colossal Biosciences have made headlines with the announcement that 3 genetically engineered wolf pups, Romulus, Remus, and Khaleesi, were born after scientists used ancient DNA from dire wolf fossils to edit gray wolf embryos. What exactly happened here? And is this a true resurrection of the dire wolf species, or are we really just looking at modified gray wolves?
Well, essentially it is modified gray wolves. So what happened here is that Colossal managed to sequence the genome of, I believe, 2 dire wolves, so 2 different dire wolf fossils from animals that went extinct, or that died, I think, one 13,000 and one 75,000 years ago. And then they compared these genomes to the genomes of different canine species. And then they identified various differences between those ancient dire wolves and modern wolves, and they then went on to take modern gray wolf genomes and edit them in a few spots to make gray wolves that look more like dire wolves.
Well, the company is calling this the world's first successfully de-extincted animal, but not everyone agrees with that term. Why is that the case, and how exactly do we define de-extinction? Is it about recreating an exact genetic replica, or more about reviving certain traits of a species?
Yeah, so that's almost a philosophical question. So Colossal has a team of world-class scientists, and they have done world-class science here. And I feel they're almost doing themselves a disservice by kind of simplifying or exaggerating this achievement, which is a significant achievement. In terms of de-extinction, the dire wolf genome differs in conservatively 1 million places to a gray wolf genome, probably more than that. And they've edited 20 of those places, 20 out of the 1 million. So that doesn't make the gray wolf a dire wolf, and it doesn't make the dire wolf de-extinct. It makes the gray wolf with dire wolf like traits. I don't know what the exact definition of de-extinction should be, but it feels like a bit of a stretch to call it de-extinction in this case.
Okay, interesting. Well, speaking of traits here, Dr. Knapp, the scientists at Colossal made only 20 genetic edits to gray wolf DNA, specifically targeting genes for physical characteristics like size, fur, and jaw strength. Is this level of genetic modification enough to say we've brought back a species, or is this more of a symbolic milestone than a biological one?
It's definitely a genetic milestone. Just editing the genome of a species and successfully then raising or giving birth and raising these pups is a major achievement, and that should be celebrated, and it has huge potential. It's just not the de-extinction, that we're talking about here. We're still quite a bit away from that. I think the risk that we see here is, I've already seen now headlines from U.S. administration suggesting to take species off the extinction list because we can just de-extinct them, right? So, it's no problem anymore. And that's, of course, not true. These are not dire wolves. The red wolves that cloned are not red wolves. They are still coyotes. And so there is a risk to this claim. And they overshadow the major genetic achievements that they've made, I think.
But how confident can we be that we've captured the essence of an extinct animal just by tweaking a few genes? Could there be deeper genetic complexities that we're missing here?
Yes, it's probably fair to say that you're not going to capture the essence of an extinct animal by tweaking a few genes that affect how the animal looks. There is more to an animal. There's behavior, there is their place in ecology, which you will not achieve by tweaking a few genes.
Right.
Yeah.
Right. Well, let's shift slightly and look at the purpose behind this efforts, though. I mean, Colossal says the aim isn't just to create lookalikes, but to restore ecological functions that were lost when the dire wolf went extinct. They argue that these animals can help fill those missing niches. Is that a valid objective, you think? Can these recreated animals truly play the same roles their ancestors once did thousands of years ago?
At least controversial. The dire wolf went extinct about 13,000 years ago at the end of the Ice Age. They were living in an environment, in an ecosystem that no longer exists. So therefore, the ecological niche doesn't exist anymore. So recreating these animals is one thing, but there's still not an ecological niche here today that they would fill.
Okay, that's some interesting perspective there. Well, Dr. Knapp, but do you think that the environmental context has changed so much that trying to plug these creatures back into ecosystems could create more problems than solutions?
That's really hard to say. What is easier to say is that there are currently wolf species that are adapted to the ecosystem they live in. And they live in a very much alive ecosystem, and they are struggling. They are threatened species. And ecologically, it seems to make more sense to first look after those species that live today and that are adapted to the ecosystem they're living in. And part of the achievements of Colossal could be used to do that, to support that, which I think is why they are major achievements. But yeah, not in the way that it's publicized.
Well, on the technical front, you've previously spoken about the limitations of gene editing, Dr. Knapp. Could you share more about this, and could these genetic modifications have unintended consequences, such as affecting the animal's behavior, immune system, or ability to survive long term?
That is generally considered a limitation of gene editing at this stage. So the technology is quite new, and many genes have more than one function. So you might change a gene to give the animal longer fur, but at the same time, that gene has a different function, which will then also be altered and which may have unintended consequences. Having said that, they have achieved birth for these animals. The animals are now, I think, 6 months old. So these are that's something that is a major achievement, and that shouldn't be sold short. Clearly, there is some know-how there that is really world class.
Well, Colossal has emphasized that this isn't just about bringing extinct animals back. They also claim that the technology behind this project can help save endangered species like the critically endangered red wolf, for example. Do you think that this kind of genetic technology has real potential to prevent extinction? And in the long run, could this be a game changer in helping wildlife adapt to threats like climate change and new diseases?
I think this is where the real achievement is here, yes. I mean, it's probably not quite there yet, but you can sort of conceive a number of cases where there are certain species which have, because of the small population size, mutations that are in some way debilitated. Individuals that are still there, infertile, kakapo, for example, in New Zealand. If you can edit that out, if you can basically increase the genetic health of a population, of a small population, that is a real. At the same time, if you can improve adaptations of a species to environmental change, all of these things, which I think can be achieved in the long run with the technology that Colossal is working on here. And that's, I think, what can be celebrated here.
Amazing. Well, before we let you go here, Dr. Knapp, Colossal isn't stopping here. They're already working on woolly mammoths, the dodo, and even the Tasmanian tiger. I mean, this is really giving the idea of resurrecting lost species, and it seems to be gaining momentum. Do you believe that this growing push toward de-extinction is ultimately a good direction for science and conservation, or not really? I mean, what excites you most about where it's headed, and what concerns you the most?
What excites me is what I said before, the possibility to improve genetic health of certain species with this technology. That's fantastic. What concerns me at the moment is the hype around supposed de-extinction and the consequences of it. As I said, when we see a U.S. announcement of taking species of the threatened species list, because we have this cool technology to bring them back if anything happens. that's going entirely the wrong direction and is absolutely counterproductive to conservation and a real concern.
Well, thank you so much, Dr. Knapp, for your time and your insights today.
Thank you very much.
Thank you. That was Dr. Michael Knapp, who is the Associate Professor in Biological Anthropology at the University of Otago. This has been The Big Story with me, Hongbin Jeong.
To listen to more great interviews, download our podcasts at audio.sg or download the audio app. That's AWEDIO, audio at the App Store and Google Play.